Josh Bowen. I work at Celestia, mostly focused on kind of like the execution layers on top of Celestia.
Right.
Hi, everybody. I'm Seeram. We've been working on a project called EigenLayer, which essentially enables each stakers to provide other services. The first example of which we're building is a data availability service called EigenDA.
Hello, is this working? Yeah, good. Yeah, I'm Dankrad. I'm a researcher at the Ethereum Foundation, and I mean the data availability layer that I'm working on is like sharding, which has been part of the Ethereum roadmap for a while, and now it's pivoted to mainly a data availability layer, at least for the next few years.
Great. So I guess my first question is, do you think data availability layers are winner take most? Like, what are the network effects? And is it really a very strong competition between the three of you, or are there like opportunities to have multiple winners?
I think there's a strong argument, just like structurally, that there is benefits for more rollups to be within a single data availability layer. The bridging guarantees there are better, but I don't think that necessarily means it's going to be like a winner take all. There will be only one DA layer, but I do think like the network effects imply there is strength to like becoming the dominant DA layer.
Right.
I think I would agree on that. I think one of the things that builds into this is the idea that data availability can be made scalable. The fact that data availability can be made scalable means that one layer can grow large. But there is another counteracting force to this, which is the native coupling of data availability with the native chain is actually gives the highest guarantees always. And so I think the way we will see things evolve is on a given domain, the most secure data availability will be native. And then there'll still be a lot more needed, and we are there to supply that.
Yeah, I think I would agree with Seeram there that like there's basically like, say from the Ethereum point of view, there will be the Ethereum data layer, and then there will mainly be the others basically. And I think like the Ethereum data layer is unique in that in there you get very high guarantees, and the others give you like a different level of guarantees, but in that guarantee they're more or less fungible. Yeah.
Right. Okay. So in terms of scalability, like it sounds like you say you can have unlimited scalability, but like would you agree that you can have unlimited data availability? Like why are we not doing that at the Ethereum layer? And like what are the trade-offs here?
So the main limitation about data availability scalability are that they are kind of they're a bit than strict, sort of like they're not limits of nodes, but they are basically more based on we don't want to lose data. Ultimately, what makes us not lose data is always interest. We want to preserve some piece of data forever. There's no storage medium that lasts forever. There's only people who keep being interested in the data and keep making copies. And so fundamentally, I think that will always be the limitation to how far you want to scale your data availability, how far you are willing to compromise, how much you think there's interest for your data availability layer, and how far you think you can push that. So it's not unlimited. It can go quite far, and it does scale also like with how important your platform becomes ultimately, which is good, but there will be limits.
Seeram, do you agree with that? That in order to guarantee that the data will stay there forever, you need interest, and like how are you going to build interest?
So, modularity is our answer here. The idea that what we will provide on our layer is only short-term data availability, in which case each node does not store all the data. Each node stores a small portion of the data for the small period. Both the network bandwidth requirements and the storage requirements are rather small because you're scaling across the n nodes. And whether data needs to be stored perpetually, I don't know. I think a lot of data is evanescent and needs to be thrown out.
Yeah, I just agree with that. I mean, the guarantees we availability are that there was an agreement that the data was available this block time. After that, everything is kind of altruistic general. You know, in like an existing blockchain, right? You say you have a storage at the time the block was produced. Theoretically, all of the nodes could trim that data, you know, immediately, right? So we are assuming that there is some period of ability. You know, the Bitcoin guys, I think, argue about like your recomputation stuff, but generally we're with there being data that goes away after some period of time. You know, for applications, you know, your requirements may be like a tax year, right? Like you have to have, you know, your records as long as you have to file taxes for it. After that, it's a question of why do you care about the trades you made 3 years ago?
What was the question?
I have a small comment on that.
Yeah.
The availability guarantees are required, for example, to continue running a rollup. But to do this, the only need is the state. So as long as you've stored recent transactions and the state in a scaled data availability layer, whether you need to kind of bootstrap that rollup from history and Genesis is a kind of option which is only needed for very high security applications. There'll be a lot of other applications for which that will be an overkill. Like you play, you know, you start to do a computation which is evanescent, and you just do a benchmark that state perpetually. So that's our.
Right. So I guess one question is in terms of planning ahead for the next year, the next decade maybe, like how much demand expect there will be for data availability, and can you provide for all, can you satisfy the world's demand, and how large is that?
I mean, that's going to depend on how long we're in a bear market. There's not a lot of strong demand now.
Right, I see.
One thing I would say, a lot of rollups have worked very hard in and making sure that very limited data needs to be returned. And I think the only thing we know how to do scalably provide in a decentralized system is data availability. So it seems like once people realize that there is a data availability, there'll be a new class of applications that can be enabled based on that. The way I think about it is not just throughput, it is also the. So imagine competing with a single server system. What is the comparative cost of your distributed system downloading and storing that data? As this, you know, we can actually get this to a small factor, like a 2x for a 50% redundancy or a 10x for a, you know, 90% redundancy. I think there is a large scope of, once the comparison to a centralized server is very minimal, you can start doing things that you would not be on blockchain. So our thesis is we need a lot of data availability. Once you have data availability for cheap, you can start moving applications not thought to be possible on a blockchain.
We would all probably be better off if we didn't all have to hire people like T11S to gas golf contracts. So more data availability can help us there.
So, you know, talking about, you know, all these challenges to production, you know, the auditing and whatnot, like, who is going to be the first mover? When production?
Soon.
Soon?
This is one thing I learned. Don't make time commitments. I'm aligned here, so we follow the protocol. Yeah.
I think you have strong opinions, Dankrad, like in terms of cleanliness.
I mean, yeah. I mean, I think definitely like move very soon. I don't know like who's gonna be first. Clearly, it depends also what exact trade-offs you're willing to take, which is I think very different between the different protocols. I think for Ethereum, it's sort of this first thing, that 4844, that's gonna hopefully be within 6 to 12 months or so will be live, but full like data in a scalable way will probably take more like of the order of 2 years, in my opinion.
Yeah, I mean, going a little deeper than just saying soon, Celestia intends to be kind of the first mover in this space. I think we've been working on this problem to some degree a lot longer than everyone else. And, you know, as Dankrad mentioned, different kind of needs here. It's harder to integrate, you know, use case into an existing network. There are obviously benefits for that, right? Once DA is, you know, in protocol to Ethereum, you have what, 100 $1 market cap kind of securing that. So your security guarantees are much higher. Celestia can't hope to reach that, overnight. But we do think we'll be able to be the first mover. We have, some prototypes working internally. We do have a net that is live and has been live for several months now.
Mm-hmm. Now, I have a worry, which is that the way that blockchains secure themselves is by selling block space. That's their source of income. Now, it sounds like data availability could potentially be like a commodity, which is cheap. And so does this compromise the revenue model and therefore the economic security, the market cap of the, therefore like the whole model itself, because data availability is by economic security. So how do you see that?
Our view on this is, I think, fundamentally there are three distinct costs required in maintaining a data availability layer. I think it's very similar for other. Number one, you have the operational expenses. You have to actually run nodes which download, and they have to pay for networking, they have to pay. This is operational costs. There's also economic security that is underwriting whatever service is being provided, and this is on the cost of capital. So if you want $10 billion staking, you need 10 PR or whatever. So you need to pay back $1 billion back to the. So this is again another important concept. And the is congestion cost, which is you have to pay for the externality you're inflicting on the rest of the network. So as you hit closer to capacity, you pay a fee. I think right now what we are seeing is are fundamentally only charging congestion costs. I think this is not really tenable. We have to have systems charge all three costs. The first one, which is, the operational cost is really in per byte. Right? The capital cost is in per dollar. And congestion cost is in per externality induced and how close you are to the capacity. I think as we grow this industry, block space becomes like cloud space. There is no such thing. There is cloud congestion on Amazon, and that's why you're paying for the operational expenses for Amazon doing the thing that it's supposed to. And when we think about pricing in our layers, we take a lot of care. Sure, there is no congestion. When there is no congestion, and the dominant cost is capital, because operational costs are usually dwarfed by the cost of capital, and the dominant cost is the cost of capital, then what happens is the more the rollups, the lower the per byte fee. For the first time, we see positive same-side externalities. The more the rollups come, sharing in the same dollars worth of security, per byte actually goes down. And this leads to a really powerful flywheel where more and more people want to participate. And that's how we think about pricing in our systems.
Super interesting.
I think congestion costs and focusing excessively on congestion costs is the only way to be viable implies you're kind of user hostile to some degree. Like the data layer to try to be, charge users a high amount and artificially limiting the amount of data it can provide. Yes, there's limitations being a commodity. No business really wants to be a commodity if it, doesn't have to. We want to be, we're trying to provide public goods here, right? We want to provide, shared data availability for many use cases. We don't want to be artificially limiting something that we can technically provide simply because we want to be returning a higher profit to validators. We have to assume demand for block space ahead of what we're currently able to provide, and that if we provide that, if you build it, they will. Right? If we can build very cheap block space, then there will be people who will find useful things to build on top of that cheap block space.
Just one thing I want to add is it's not fully fungible, like I said earlier. I think when the data with the core settlement layer, you have higher guarantees and people will be willing premium for it. That adds to the other point that Dankrad mentioned. The core philosophy underlying something like Ethereum is you want enough power to maintain the ledger, and that is itself a huge in addition to the short-term data availability. And having these sets of guarantees bundled into one does provide a certain charging power available to others.
Josh, one thing you mentioned is that if we were to artificially constrain the block space, that would go to the validators. It turns out there's a way to have it go to the token holders. Do you think that would be a thing? And in the context of Ethereum, we have a lot of income, right? We have so much more income than, in a few days, with the supply has been decreasing. And it's to our advantage for Ethereum to be like the amount of supply that we provide. Do you think it would be acceptable to do that if the income would go to the token holders as opposed to validators?
I mean, I think you can compare this to like many web apps, right? Where you often have, a user acquisition growth phase, and then you have a period where your VCs show up and they want to get paid, right? So you can say, okay, we have a sufficient number of users that hold Ethereum tokens, and we're now going to go and pay, dividends to all of these token holders based on our block fees. But that's going to reduce the amount of users inbound because you've artificially priced them out, I guess. Depends on what your intention is. Do you want more users on your network, or do you want to reward users on your network?
Well, I could argue that there would be more users if the income goes to the token. Then you have more economic security that attracts more users. So actually, there is a positive feedback loop.
But I guess if you're focusing on like the security, like I feel like security is something that, like there's a threshold for it per user, right? Like
Right.
I think most people would argue that like at a point of like sufficient security, it would be beneficial if it was higher. Generally, we're assuming with proof of stake there is no individual actor sneak through and own a large portion of the stake. I think many people would know happening. I don't think that number needs to be $1 trillion to prevent someone from acquiring all of this stake. From a user coming in who says, okay, maybe I want to go day trade some tokens on a roll-up on Ethereum, are they going to say, well, am I willing to spend $1,000 because there's only $150 billion worth of economic security here? That's probably not going to be. But if they say, okay, it's going to take me 1 cent per trade versus going to take me 10 cents per trade, right? That may be essentially a more limiting factor from an end user's perspective.
Okay, interesting. Dankrad, do you have any thoughts on the economics of data availability?
I mean, I think so your question is kind of a little bit biased because it feels like you're thinking that demand that it will like that as goes down because you have more data availability, the total fees paid will go down. But I actually that the total fees will increase in total. So I'm not really worried about the economic security, at least not at the high level of security that those that would decide to directly settle on Ethereum would be.
Yeah. Right. I mean, I would tend to agree. Like I mean, it's something we've seen historically with Ethereum. The more we scale, the more induced demand, the greater the total fees.
So the individual keep going down, but I think the total aggregate fees will go up as we scale.
So that is what I'm hoping for.
Yeah.
But there is a that was put forward by Polinaya, and his argument is that once reach sufficient capacity, sufficient scalability, there's just demand, beyond, let's say, 1 million transactions per second or 10 million transactions per second, and then there will be like a huge cliff, and it will catastrophically go down. Like, do you see that as a big cliff, or do you continue?
The total amount of data availability demand is pretty complicated. This is basically asking how far our industry can grow, and I think we're all built here because we're very bullish about what we can do.
Right.
But in terms of the pricing model, I think once you this three-pronged pricing, which includes operational cost, capital cost, and congestion cost, I think this appears extremely second. You can start saying that if you need $20 billion in stake, then you have to return fee and you amortize that fee across all data availability users. So you can calculate this over a running average for the per month or something, and then price security fee, which is based on the total amount of dollars at risk. So I think by coming up with innovative economic models, we can, even if there is infinite supply, I think it's able to charge, because you're not charging for the data availability, you're charging for the economic security. So the pricing should directly reflect that, as opposed to reflecting really through congestion costs.
I mean, you are basically arguing that I think there will be several data availability markets. There will be the best one, and there will be a premium one, which is because you get direct settlement, like direct interaction with the settlement layer and so on. And I think that is the difference. Like in a market, you charge your cost, but you charge congestion if you are. a premium product. So that's the difference.
But this issue is even true for Ethereum, right? If you suppose make capacity infinity, even on a premium layer, the price might go to zero.
But I argue we can't. Like, I mean, I think this is, for example, one of the differences we had actually, that I think, like, so we would argue that data on Ethereum should always be preserved. That's not a protocol property we provide, but that's a social property we have. And I think that property is one we are not willing to break, so that will provide sort of a certain barrier. Yeah.
I think that's a high level of service for which people will be willing to pay.
Exactly.
So,
Seeram, I back a little bit on your thesis that the capital cost can be amortized. The reason is that there's this concept that I call security ratio. Basically, the total value secured divided the economic security. Now, on Ethereum today, it's about 20x. As we have $0.4 trillion secured in NFTs, ETH, and ERC20s, and we have $20 billion in. And I guess if we want to have an invariant, let's say we want to have whatever a security ratio of 100, then anytime someone comes in, they need to contribute towards increasing the economic security. Don't amortize anymore. Would you agree with that?
The thing is, as users coming in, so if you apply this thesis, right, like 3-4 years, Ethereum had, like, if it was proof of stake, it would have had 100 million security, right? But today there is $300 billion in use case. Is that they're all paying a fee that contributes back to the value of the token, by 1559 and fee payment and staking and other things. So I think the same thing will be true even for a system like this. Is as new users come in, and maybe these are users who don't need very high economic security, like they're playing a game, running a social network, they're doing other things, and they're okay with marginally increased like capital cost, and as these users come in, they're all paying a fee together, which increases the value of, drives forward more staking. So I think it's the system can self-scale.
Okay, optimistic.
Yeah, I think there's like a general question of like, does the use of the data availability, like new users use up more, or will they try to secure more assets than like the current ratio?
Right.
But if we see much more data availability at lower cost, I think there's a likelihood that we can support less financially valuable transactional. Say right now, right, the transactional is so high, we have primarily financial use cases because it's very easy to calculate that it's worthwhile to make this transaction because I get a profit. If you're going and playing a game, say, well, how much economic security did you need for your game, or how much like economic security value were you like storing in your like 30-minute ephemeral game? Like, did that really take away from the security? Like, probably not. So we can see a lot more use cases that don't pay from the security budget in your ratio case.
Right. We have time for one last question. I guess we can open it up to the audience. Anyone? Very good burning question. Yeah, go ahead. I can repeat it.
Right. I don't know if it's a good burning question or it's a question all the same. So one of the obvious tenets of Web3 is that we should all be able to control our data, control our information, but then also have the ability and the freedom to move to another platform if we're not happy with the existing platforms we're on. So I think the thing that I'm missing when we talk about data availability and duration of holding data is what happens if I platforms, but all of a sudden the data that I want to take with me is no longer there. So imagine like you have some social, application that's now on blockchain, and you have all of your followers, and you have your entire community, and perhaps like tweets. Like, is this the data that we're talking about that's not available after some period of time, or are we talking about something else?
Anyone want to take that? I have an answer, but
I guess, it depends on like the pruning guarantees, and I'm not going to 4844 or like the timing of like the pruning, right? But like it's this question of like the guarantee at time of new block, and like there's fundamentally a difference, I think, between like a data availability chain and like a data retrieval market. And like a data availability chain is guaranteeing that there was security and a consensus around like the set of state at some period. State is like a nebulous, bag of bytes, we'll say, but guarantee that your data will be retrievable for all time. But if like an active social network or something and you have active usage, the assumption is that state wouldn't be pruned because there is significant economic value state. But I guess like in the moving thing, are you thinking like, you need to dump all of your data off of it and like move it somewhere else? Presumably you just query it off of the chain and then do that. And then for your application to continue using at any given time, right, all of the data you need to be present, right? It's the difference between state and history.
I mean, I think, like, to clarify, I think, like, your question is about data storage and not data availability. So, like, actually, the platform you want to go to is IPFS or something like that, and not a data availability layer. I would argue that Ethereum will be as good, but it will probably be too expensive for your application in practice in the long term. Maybe for the next couple of years, it might be fine.
All right, thank you guys. That's all the time we have.
Thank you.